Hello, this is Martha once again, and we're going to continue on with our pre-calculus final review. This time we're going to cover problems 28 to 32, and these are about logs and all sorts of fun properties with logs. So number 28 says, write in logarithmic form 4 cubed equals 64. So I'm going to draw my little arrows because that's how I remember it, and my exponent always goes to my equal. So this is going to equal 3. And I'm going to have a log base 4, 64 equals 3. And that's just remembering that the base, the number attached to the exponent goes to the base. And then it equals is what the base is multiplying, and then the exponent is the equals. All right, now we're going to sketch the graph of f of x is the natural log of x minus 2. Show its intercepts and asymptotes. So this is just a transformation. So we're going to take what we know about our natural log function. It hits at 1, 0. There's a vertical asymptote here at x equals 0. And it goes up like this and down, reaching towards the asymptote. Now this ln of x minus 2, because it's inside the parentheses, we're going to move 2 to the right. So 2, 3. So it's now going to hit the graph at the point of 3, 0. And that asymptote is still 1 away. So that vertical asymptote is x equals 2. And it's the same graph like that. And this is just a basic transformation. All right, now we get to combine logarithms. So write the logarithm of a single quantity with a coefficient of 1. So we're going to use the power rule. So what we're going to do is we're going to bring the coefficient up as the exponent for each of these. We're going to have log base b of 16 to the 1/4, and then we're going to have minus log base b 5 squared plus log base b of 7. And we can see that they each have, it's just a regular log with the same base. So now let's take care of our exponents a little bit. So what's the fourth root of 16? Well, if we go 2 times 2 times 2 times 2, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we know that this log 16 to the 1/4 is log base b of 2. And similarly, we have log base b, and we'll take care of that exponent right now. 5 squared is 25 plus log base b of 7. Now, the subtraction or the quotient rule for logs says that because these two things are subtracted, we can combine that because they have the same base of log base b. It's 2 over 25 plus log base b of 7. Now we can combine this logarithm even further because we've got a plus in between. That means we're going to link it to multiplication. So we've got log base b of 2 times 7 all over 25. Multiplying that out, we get log base b of 14 over 25 as our answer. Wahaha! Now, number 31 is solve for x. We've got 3 to the 2 raised to the 2x power equals 81. Now, if we can get this 81 as a base of 3, that can help us out. So we're going to write 3 to the 2x because that's what we're given. And how do we get 81 to be with an exponent of 3? So let's try this out. We're going to write 3 a few times. We're going to go 3 times 3 is 9. 9 times 3 is 27. 27 times 3, that's 81. So 1, 2, 3, 4. 3 to the 4th is the same as 81. And because we have the same bases, we know that our exponents have to be equivalent. So we have 2x equals 4. Solving for x, we divide this by 2. We get that x equals 2. And that's our answer for 31. 32, we need to solve for x, but this time the x is the base of the equation. So again, we're going to draw our arrows and remember that the equals becomes the exponent. So 32, x to the 1/2 equals 5. And so I can square both sides, because that's still within the rules. X, the square root of x, or x to the 1/2 squared, just equals x. 5 squared equals 25. And that's how I get my answer. I hope this was helpful and have a great day. Have some fun.